In the previous video, we learned that we could hydrolyze an ester using acid. We just take the ester, dump it into the water with some strong acid, and we can go to a carboxylic acid. Interesting thing is that you can also do this with base. So we start off with an ester in water, but we add some base, just throw in some sodium hydroxide and maybe cook it up a little bit. You'll also get to the carboxylic acid. Now, how does this work? Well, it's pretty easy to figure out. We'll take our hydroxide. It's a good nucleophile. And where do we attack? Well, the sender susceptible to nucleophilic attack, of course, is the carbon. It's got the positive charge, or the partial positive charge of the carbonyl. And so we can simply attack that carbon, push the negative charge out onto the oxygen. And this gives us our famous tetrahedral intermediate. Well, what we want to do, of course, is get rid of that ester. And it turns out we're already ready to do that, because this negative charge wants to reform the carbonyl, and it can do that in two different ways. It could just come on in here, reform your double bond. That's all right, missed. You just reform your double bond, and then you kick out a group. Well, you could kick out the hydroxide that you just added, but that'd be kind of boring. And it'll happen some of the times, but more interesting is, of course, is to kick out the ethoxide. And so if you do that, and you continue on, you've gone back to your carboxylic acid. Now, this carboxylic acid is sitting there in base, and most of the base, of course, is going to be hydroxide. So what's it going to do is it's going to immediately react with some more of that hydroxide, and it's going to give you the carboxylate. So our net reaction is actually not going from the ester to the carboxylic acid. It's going from the ester to the carboxylate. If you really want the carboxylic acid, then in a second step you'd add some acid and protonate that carboxylate and do it. So this would be a second step now. You're going to add some acid. Maybe you're going to throw in some going to throw in some HCl, let's say, as a separate step, and now you're all set to come and protonate the carboxylate and end up making your acetic acid. Now, this is very nice. In the conditions of acid, we could show that we could do the reaction either way. We can convert, in acid catalyzed condition, we can convert an acid, carboxylic acid, into the ester back into the carboxylic acid. What about doing the reverse here? Could we take a carboxylic acid? Okay, let me just draw one out here. I'm going to go steal my ester for a second and convert it to a carboxylic acid. So I'm going to just change this to an acid. So this is an acid. So now, what I want to do is, could I put this in a solution of an alcohol? Okay, so I want to try to do the reverse reaction. So I'm going to have some there's some ethanol, and I'm going to make the ethoxide. So let's see what happens. So I can do this ethoxide. And so the question is, can I just do the same reaction? Could I just attack the carbonyl and get the tetrahedral intermediate, and we'd be on our way? Well, there's a problem. What's the problem? The problem is the ethoxide is not going to attack the carbonyl. What is it going to do? It's going to attack the proton. So, and give you back the carboxylate. So this reaction is over before we start. You can't use basic conditions to make an ester from a carboxylic acid. You have to use acid. Going the other way, converting an ester to a carboxylic acid, you can use either acid or base catalysis. So both works two ways. Making the ester, you have to use acid conditions.